Good morning, everybody. Respected Principal Sir, HOD Sir, my dear colleagues, and my beloved students. Today's day, that is 16th November 2013, will be a memorable day in the history of SIT. Because on this day, we are going to organize the event of its first time. Here, in total, there are 12 experiments, and students who have learned these experiments during their laboratory sessions will give a live demo. There will be an interaction between the students of different colleges, and in this demonstration, students from both sides will be mutually benefited. The 4 students who have not got the opportunity to learn during his laboratory session or during his class session will get a chance to once again groom himself or herself. This workshop aims at 2 directions. Our students will learn, they will understand, and at the same time will help other students of other engineering colleges to learn at the same time. Let the learning process be a true one where there should be a perfect balance between your laboratory sessions and your technical aspects. Before I conclude, I wish very grand success to all the student participants and the volunteers. Thank you.
With the advancement of the technology and the rapid pace and modernization in the electronics field, from analog to the digitalization in its equipments and the applications, the core interest of the students is shifting and upstream the core engineering part of the analog electronics and circuit, which is a backbone of the electronics section. Despite of having the many advantages and the main role played by the digitalization, the analog part of electronics is having a crucial role for developing the major electronics equipments for determining its operation from high-bus circuit to the active electronics and communication engineering of Editing Screenplay Technology has organized a student workshop on relevance of the analog electronic circuit. The theme of the very workshop emphasizes the learning process of the student. There must be a strong interaction between the demonstrating and the waiting students. The students may get the training ways to give the curious questions, and it is obviously a great platform aimed with the greater opportunities for both the students and the teachers who are willing to renew their knowledge in the analog electronics of the very workshop, demonstrate their own experiment and provide an admirable knowledge to the visitors in the field of the analog electronics. Let's see what they in store for us. I am the theoretical demonstrator of ADC and DAC. What is ADC? ADC is basically analog to digital converter, and DAC is digital to analog converter. Device which converts digital to analog signals and analog to digital signal and vice versa. So now I am discussing 2 types of digital to analog converter. One is weighted resistor DAC and one is R2R ladder type DAC. What is a weighted resistor DAC? If I analyze the circuit given here, I am using a summing amplifier of IC741, nothing other than a current to voltage converter. Over here I am giving the current, I am using switches of single pole double throw. What is single pole double throw? It is there are 2 pins, one is in the ground mode, one is we are connected in the reference voltage VR. Participant Shomona Tarikdar will give demonstration of digital to analog converter. As you can see, this is the digital to analog converter trainer, and we are giving the digital input by these switches S1, S0, S1, S2 and S3, and we are getting the analog output by this digital multimeter, and we are giving switch 1, and this is converting into the equivalent analog output, that is 0.312 volt. So in this way we can say that if we are giving the digital input to this, and then we can get the equivalent analog output through this digital multimeter. This is it.
This is my partner, and today we are here to discuss the relevance of analog electronics in the engineering field. So first we'll start with our topic, which is to design and implement diode clipping circuit. So now we know what is a clipping circuit, but first it comes a question that what is a clipping circuit? A clipping circuit is a circuit in which a waveform is shaped by removing or clipping a certain portion of the input signal. So we can say that a clipping circuit works as a crude or AC voltage limiter, and it prevents the malfunctioning of the circuit in the subsequent stages. Now we will take a brief look at the theoretical portion of the clipper circuit. As we see in the chart, there are 4 types of mainly clipper circuit, that is positive clipper, negative clipper, bias clipper and combination clipper. These clipper circuits are further subdivided into the positive series and shunt, negative series and shunt, bias positive series and shunt, and the combination clipper. Now coming to the working of the positive shunt clipper, here we can see the circuit diagram in which the diode is connected in series with the voltage in the collector. Over here, during the positive half cycle of the input, the diode is reverse biased, and hence the diode does not conduct, it acts as an open switch. We do not get any output. Hence, from the graph we can see that the negative positive part is clipped off. During the negative half cycle, the diode is forward biased and the diode conducts, and we get a voltage across this resistor, hence we get the positive P. Similarly, we have the negative series clipper with only the polarity change. Now coming to the positive shunt clipper, first of all, why is it called a shunt clipper? It is a shunt clipper because the diode is in parallel with the voltage. We will explain you the lab demonstration of here.
This is negative shunt clipper. Here negative portion is clipped off. Here we use an external biasing plus minus 5 volt. We can vary this biasing voltage here, and because of varying this voltage, we can measure the clipping portion, and we can measure the amplitude.
Measure the distortion and plot the frequency response characteristics. Okay. At first we will measure the output, input power. Here we measure the input voltage, input VGC voltage. We have VGC voltage 6.1, and input time here is 80 milliampere. It's milliampere. So our input will be this is
emitter voltage drop. If we do not apply any signal, so DC current will be flow through this resistor. There will be no role of any this capacitor. Suppose if now I will apply the input signal to this capacitor, this transistor, there will be a voltage drop, and this bypass capacitor, because of its very low impedance, it will try to bypass this resistor. And suppose if it is not used, so then what will happen? The whole emitter current will try to flow this RE, and there will be a large voltage drop across RE. And if there is a large voltage drop across RE, so it will get added to this VBE. This is the base emitter voltage, which will added to this emitter voltage. So which will also make our biasing circuit disturb. It's 0.6 microfarad. So that's why we need these capacitors.
6 microfarad.
Yeah, it will be very.
There has been a very hardcore fight amongst the different groups, and the judges really have taken a lot of pain to come out with a decision. I think you will appreciate it sportingly, as because it has been decided by the Department of EC that out of 11 groups, only one group will be awarded the prize.
This is all about the students' workshop on relevance of the analog electronic circuit in modern engineering. So, that's all. much.